This is lesson 3.3, Solving Linear Systems by Substitution. This is a grade 10 applied lesson, so if you are in grade 10 applied, this lesson is for you. The learning goals of this lesson are that we are learning to find the point of intersection of two lines through the method of substitution. So we've already done a lesson on finding the point of intersection from two lines, and I promised you we would do no more graphing, and so I'm making good on my promise now. We've already learned how to find the point of intersection through graphing, and now we're going to find it just through algebra, and the method that we're going to use in this lesson is called substitution. We're also learning in this lesson how to convert word problems into linear equations so that we can start solving word problems in linear systems. So let's go through the steps for solving systems through substitution. And don't forget, solving systems, if we go back to lesson 3.2, all that means is finding the point of intersection of two lines. So we're going to read the steps out together. They might not make sense at first, but we're going to apply them into the next example. So step number 1, isolate for one variable in the easiest equation. Remember, solving means we're finding the point of intersection of two lines. So we're going to be given two equations, and you're going to pick the easiest one, and I'll help you figure that out. Step number 2, sub the new equation into the other equation. Step 3, solve for the variable in that equation. And then finally, step 4, sub that variable into the other equation and solve. This might seem long. It's quite a bit of algebra, but if you hate graphing, you're really going to like this much better. So let's do example number 1 together. Please make sure you have the handout 3.3, Solving Linear Systems by Substitution. So in this lesson, we're going to go along with the handout. So I've handed that out in class. If you don't have it, please make sure you go and get it from me. So example number 1 says, use the substitution method to solve this linear system. So we know it's a linear system. Why? Well, because we've got two lines here. So if it just said solve the linear system, we could go graph it, which a lot of you hate, and find that point of intersection. Or we can use this method called substitution. So let me erase all the doodles I just did here. Okay, so just like in graphing, the first thing that we're going to do is label these equations, equation 1 and equation 2, so we don't get confused. So let's call this one equation 1, and let's call this one equation 2. There we go. All right, so step number 1, let's go back to our steps. Okay, step number 1 said isolate for one variable in the easiest equation. So I'm going to take a look at equation number 1. Sorry, so we've got our first equation here, 4x minus 7y equals 20, and then our second equation here. And we're looking for, according to our step number 1, again, we're looking for one variable that we can isolate in the easiest equation. So I can isolate for x, but I've got this 4 here. I can isolate for y, but I've got this 7 here. But take a look at this. In this equation here, x is already by itself. So that looks pretty easy to isolate for. So that's exactly what I'm going to do. We're always looking for shortcuts. If there's a way to do it faster, we're going to do it. So what I'm going to do is do step number 1. So I'll write a little step 1 note for the first time as we're doing it. So what I'm going to do is I'm going to rewrite equation number 2. So I'm going to rewrite this x minus 3y equals 10. And remember, step 1 says isolate for one variable in the easiest equation. So we know that the variable that we want to isolate for is x. If you want, we could have isolated for y, but we got that 3 there. It just seems way more complicated. So let's just isolate for x. So what is it that we have to move then? Well, we know we'd have to move, if we want x to be by itself, we're going to move this thing here. So let's rewrite it. We're going to have x minus 3y. How do we get rid of a minus 3y? Well, we're just going to do the opposite of that, which is adding 3y equals 10. Whatever I do on the left, go do on the right. So plus 3y. And then we are left with, on the left-hand side, we can cross out minus 3y plus 3y, and we're left with x equals 10 plus 3y. And there we go. So step number 1 is done. So we're going to call this, because we took, this actually came from this equation here, we're going to call this the new 2. So I'm going to call this equation 2 now. And we don't care, now that we've got it in this, we don't actually care about this one at all anymore. Now we've got our new equation 2. Alright, so let's take a look at our step number 2 now. Step number 2 says sub the new equation into the other equation. Okay, so we will do that. So we're going to do step 2. And then I'm going to say sub 2, our new equation, into our old equation, which is 1, or into our other equation, which is 1. So let's do that now. So I'm going to rewrite our first equation. So what I'm going to do is rewrite, here's our first equation, don't forget. So I'm going to rewrite 4x minus 7y equals 20. And then it says to sub 2 into it, which means that here is 2 now. What it means to substitute 2 into 1 is that every time we see x now, we're going to write 10 plus 3y. So one more time, what it means to substitute equation into another is now that we've isolated for x, every time we see x, I'm going to put in 10 plus 3y instead, because we're told that x equals 10 plus 3y. So we are going to write 4, and then instead of x, what can I write? I'm subbing in this, 10 plus 3y, because x equals it, this thing. So that means that instead of x, we can write this. So I'm going to write, instead of x, I'm going to put 10 plus 3y, bracket, minus 7y, just copying from above, equals 20. So it's, move this up. It's an art form getting this to move. Okay, here we go. All right, so now let's check what step number 3 says. Step number 3 says solve for the variable. Okay, we can do that. The only variable left here is y, so we're gonna solve for y. So now let's go to step 3, solve for y, and let's do this. We're just going to use the algebra skills that we learned in the last unit. So we can see that this 4 should be distributed there, so that's what we're going to do. So we're going to do 4 times 10 plus 4 times 3y. Then we've got this minus 7y equals 20. 4 times 10 is just 40, plus 4 times 3y is 12y, minus 7y equals 20. We can simplify 12y minus 7y. So let's write out, we've got 40 plus 12y minus 7y is just 5y. We've got, these are like terms, don't forget, because they're both y's, equals 20. We use our skills that we learned in Unit 2. We're looking for like terms. So here I see a 40 and I see a 20. So let's bring this 40 onto the other side. We know how to do that. We're going to write 40. How do you get rid of plus 40? Well, we know we're just going to subtract 40. And then we've got plus 5y equals 20. We can write minus 40, because whatever I do on the left, I got to do on the right. Then I can cross these two out. We're almost done. We've got 5y equals 20 minus 40 is negative 20. Almost done. Now, the only thing left to do is get rid of this times 5. Remember that that's a multiplication in there. So to get rid of times 5, we're just going to divide by 5. Divide by 5. And on the left-hand side, we can cross these two out. Right, y equals negative 20 divided by 5 is just negative 4. Here we go. All right. We are done step 3. The very final step. Let's go take a look at it now. Step number 4 says sub that variable into the other equation and solve. Oof, okay. So we're going to sub this variable now into the other equation and solve. So remember, the whole goal of this is that we're trying to find the point of intersection of these two lines here. So we've learned it by graphing, but now we're doing it by algebra. So our answer should be an x-coordinate and a y-coordinate. So our goal, don't forget, our goal is to get an x-coordinate and a y-coordinate. We're looking for a point here. So we've just learned what the y-coordinate is. We know that it's -4. So right now what we actually have is x, comma, and we know that y is -4. So all that we're looking for now is x. That's it. So one more time, step number 4 said sub that variable into the other equation and solve. So let's figure out what other equation that we haven't used yet. Let's look back to step 2 and see what equation was this one actually that we were using. Well, this was equation number 1. So we've got to sub this y into the other equation, which is equation number 2, which is, we know, right here, because we've been labeling equation number 2. You could also use this one. This either would work, does not matter. So let's do that. We're going to sub this. We're going to do step number 4 now. Step 4. We're going to, let's just write out what we're going to do. Sub y equals -4 into equation number 2. So we can see that in step 2 we sub 2 into 1. We're subbing it into 1. And in this one, and in step 4 we're subbing it into 2. Well, so let's refine what equation number 2 is again. Okay, let's go up here. Equation number 2 is, let's use this one here. Doesn't matter which one you use though, remember. I said you could use this one here or this one here. So we're going to use this one here. Doesn't matter though. X equals 10 plus 3y. So we're going to remember that. Equation 2 is x equals 10 plus 3y. And just as a reminder, that was equation number 2. All right, so let's sub y equals 4 into it. So we're going to do that. So we've got x equals 10 plus 3, and instead of y, we're going to write -4. So we've got -4. And let's keep on going. Here we go. We've got x equals 10. Positive 3 times -4 is going to be -12. X equals 10 minus 12, which is -2. So let's write a little conclusion. So therefore, we found that x equals -2. We also found that y equaled, if we take a look up here, y equaled -4. So the point of intersection is -2, -4. And don't forget that the reason why we write that is because points are written as x comma y, like that. So that's how we got -2, -4. Done. So we could have, if we had just graphed these two lines up at the top here, if we had just graphed these lines, we would have actually found the exact same point of intersection. So yes, it's a lot of algebra. It seems like a lot at first. This is one of those lessons where you're going to have to practice in order to get really good at it. So let's do the next example. Okay, so example number 2 says, use the substitution method to solve this linear system. So we could use graphing, but we're not going to use graphing. We're just going to use substitution. So the first step before we're going to look at our steps is, remember, we're going to label one of these 1 and one of these 2. Okay, so substitution, let's go to our steps. Here we go. Steps for solving system through substitution. Step 1, isolate for one variable in the easiest equation. So let's take a look. We've got 2 possible equations. I'm looking at equation number 1, and I notice that this x is kind of hanging by itself, so it would be pretty easy to isolate for because I'm just going to move this over. And I look at equation 2 and I see, oh, this x, we are lucky, this x is also hanging by itself. So we just move this over and isolate for that x. So both of these are actually really easy to isolate for. So it doesn't matter which one we pick, but since we isolated for equation number 2 last time, let's do a little different, and let's isolate for equation number 1 this time. So we want to isolate for x. We're going to bring this over here. So let's go ahead and write that this is step 1. Okay, so we're going to rewrite equation number 1. So we're going to write what x plus 4y equals 5. And remember, we're going to isolate for a variable. Much easier to isolate for x than for y because we've got that pesky 4 right beside it. Let's just isolate for x, which means we're going to move whatever's left over onto the other side so x can be by itself. So we're going to write x plus 4y. How to get rid of plus 4y? Well, we're just going to subtract by 4y. Then we've got equals 5. Whatever I do on the left, I have to do on the right, so minus 4y. On the left-hand side, I can cross these two things out. And on the left, I've got x equals, and then we've got 5 minus 4y. Here we go. So we're going to call this the new number 1. Okay, I don't even need this one anymore, so I'll do a cross out. So we've got our number 2 and our number 1. So I think we're ready for step 2. So let's go to step 2 now. Step 2 says sub the new equation into the other equation. Okay, we can do that. So here's our new equation. We're going to sub it into the other equation, which must be 2. So step number 2 says we're going to sub the new equation, so 1, into our old equation, which is 2. Let's do that then. So let's rewrite our equation number 2 first. So we're going to write x plus 2y equals 7. And then we're going to sub 1 into this equation. So if we want to make a little note, this was equation number 2. All right, so equation number 1 now says that x is equal to all of this. So instead of writing x, we can just write 5 minus 4y because x equals 5 minus 4y. So what I'm going to write instead of x is, I'll put it in brackets, 5 minus 4y instead of x. And then we can put plus 2y equals 7. So let's rewrite this all without brackets now. We've got 5 minus 4y plus 2y equals 7. We know that we see some like terms here, so we can add them together. So we've got 5 negative 4y plus 2y is just negative 2y equals 7. So now we have completed step number 2. We've subbed 1 to 2. Let's go take a look at what step number 3 is again. Step number 3 says solve for the variable. So that's what we're going to do. We're going to solve for the variable. In this case, it is y. So let's do that. So I'm going to write step 3. We're going to solve for that variable. So here we go. We want y to be by itself, so we're going to, I see some like terms. I see this 5 and this 7, so I'm going to bring the 5 over here, so it's beside the 7. So, here we go. Let's rewrite this. 5, I want to get rid of that 5. How do I get rid of a plus 5? I just subtract 5. And then I've got negative 2y equals 7. Whatever I do on the left, I better do on the right, so we're going to do minus 5. So we've got 5 minus 5. Those just cancel each other out. On the left-hand side, we've got negative 2y equals 7 minus 5 is just 2. We're almost done. All we have to do now is get rid of this negative 2 that's beside the y. We know that this is multiplying. So how do you get rid of a times negative 2? Well, we're just going to divide by negative 2. Divide by negative 2 on the left. Divide by negative 2 on the right, and we're almost done. We can cross out times negative 2, divide by negative 2, and we're left with y equals 2 divided by negative 2 is just negative 1. Put into your calculator. So just a reminder, we want the point of intersection. So POI, which is just x, y. So what do we have so far? We have half of the point. We've got what y is. Y is -1. And now we just got to figure out what x is. So let's go ahead to the final step. So the final step of solving through substitution is step number 4. Sub that variable into the other equation and solve. So we know in step 4, we are going to sub y equals -1 into, and we got to figure out what equation is it that we haven't used yet. Okay, so we subbed 1 into 2 here. So we've got to use the other one. We're going to sub now y equals 1 into 1. So let's go do that. Where do we have number 1? Where do we have number 1? We're looking, that's why it's so important to label. Oh, here we go. We've got number 1 is right here. We've also got another one there. Doesn't matter which one you use. Does not matter at all. Let's just use this one here because we've already sort of done the work to help us out by isolating that variable. Oh, I forgot to memorize what it was. Okay, so it is x equals 5 minus 4y. So let's write that. X equals 5 minus 4y. And just as a reminder to yourself, that's equation number 1. And now we're going to sub y equals -1 into there. So we've got x equals 5 minus 4. And then we're going to put, instead of y, we're going to write -1. So we've got on the left side x, and then on the right side equals 5 minus 4 times -1. Remember, bad math, we do multiplication first before subtraction. So let's do this. -4 times -1 is just +4. So we've got x equals 5 plus 4, which is just 9. All right, so we've actually finished. We've got our point. So let's write our little statement here. So we can say therefore, we know that x equals 9. And what did our y equal again? Oh, y equaled -1. So the point of intersection of the two lines is, we write the x first, we've got 9, and then the y, -1. And just as a reminder, we write points in this form, x first and then y. And we are done. So you could have found this exact same answer if you had just graphed those lines. You should have found the point of intersection 9, -1. Okay, so we're going to work on the final example, example number 3 now. Hopefully you will have been getting the hang of it. If you think you've got it, what I want you to do is pause this video, try this example on your own, and then fast forward to make sure you've got the right answer. So if you are joining us now to make sure that you've got the right answer, this question says, solve the linear system by using the substitution method. So remember again, we're just looking for the point of intersection. So we're going to do the exact same steps one more time. We're going to label the lines. So let's label this one 1 and this one 2. Step number 1 says, isolate for one variable in the easiest equation. Okay, so I'm going to take a look at my first equation. This x is not really, it's good, it could be isolated, but it's not really easy because we've got this 2, but this y is hanging by itself. So far this one's looking pretty good. On the right hand side we've got 3x, so x is difficult to isolate for and so is y. So it looks like this is the easiest one to isolate for. So let's do that. So what we're going to do is we are going to isolate for y in equation number 1 because it's much easier. So let's go step number 1. We're going to isolate for the easiest variable, which we know is in equation number 1. So let's rewrite equation number 1. We've got 2x plus y equals 2. We're going to isolate for y, so this 2x has got to move on to the other side. So we are going to write 2x. To get rid of it, positive 2x, we know we're just going to subtract 2x. Then we've got plus y equals 2. Whatever we do in the left, we've got to do in the right. So we've got minus 2x. On the left-hand side, plus 2 minus 2x. Those just cancel each other out. And we're left with y equals 2 minus 2 x. And we're going to call this our new number 1. So we don't even need this one anymore. We got our new one. We've got a new number 1. So we've got our equation number 2 and our equation number 1. So let's go back, check what step number 2 is. Step number 2 says sub the new equation into the other equation. So here we go. So step 2, sub this new equation, so we're going to write it out. We're going to sub our new equation, which is 1, into the other equation, which is 2. So let's start with 2 now. So we're going to write 3, oops, change my color, here we go. We're going to write 3x plus 2y equals 5, and just as a reminder to yourself, this is equation 2. And we're going to sub 1 into it. What that means is, here's 1, and every time I see a y, I'm going to substitute it for 2 minus 2x. That's what this equation is saying. This equation is saying that y is equal to 2 minus 2x, so I'm going to do that. So every time I see a y now in this equation, I'm going to write 2 minus 2x. So let's do that. We've got 3x plus 2, and there I see a y. So instead of y, I'm going to write 2 minus 2x. I should write in this one. 2 minus 2x. Here we go. And bracket equals 5. So step 2 is complete. Let's write step 3 now. What is step 3? Let's go back. Step 3 says solve for the variable. Okay, we can do that. So step 3, we're going to solve for the variable. In this case, the variable is x. Here we go. So the first thing I see I can do is distribute this 2 into here. So that's what I'm going to do. So I'm going to write 3x plus 2 times 2 plus 2 times negative 2x. We're distributing the 2 equals 5. Let's continue to simplify. We've got 3x plus 2 times 2 is just 4, plus 2 times negative 2 is just negative 4x equals 5. I can see that I've got like terms on the left-hand side here, so I can do 3x minus 4x. So 3 minus 4 is just negative 1x. So we've got negative 1x plus 4 equals 5. Almost done. I see I've got a like term here. I've got this 4 and this 5, so let's move the 4 right beside the 5. We've got negative, instead of negative 1x, I'm just going to put negative x. Plus 4, to get rid of a plus 4, we know we're going to subtract 4, equals 5. We're going to subtract 4 on the left-hand side, on the right-hand side. These two cross each other out, and we're left with negative x equals 5 minus 4, which is 1. Last thing we got to do, get rid of this negative. Don't forget that this is actually a negative 1. So how do you get rid of a negative 1? Well, that's easy. We just divide by negative 1, because don't forget that this is multiplying. Divide by negative 1 on the left-hand side, on the right-hand side as well, and we're left with cross, cross. X equals 1 divided by negative 1 is just negative 1. Let's check back with step number 4 now. Step number 4, our final step. Sub that variable into the other equation and solve. So let's write step 4. We're going to sub this new equation, so x equals negative 1, into the other equation. Let's check what the other equation is. Well, here we subbed it into 2. So here we must be subbing into 1. So let's copy down 1. And I can see that my equation 1 is right here because I've been labeling everything. Y equals 2 minus 2x, so I'm going to copy it down below. So I've got y equals 2 minus 2x. That is our equation number 1. We're going to sub in x equals negative 1. So every time I see an x, I'm going to write negative 1. So I've got y equals 2 minus 2 times negative 1. We've got y equals 2. Negative 2 times negative 1, we know is positive 2. So we've got y equals 4. So now we've got our x and we've got our y. So now let's write it out. So therefore, x equals negative 1, y equals 4. So our POI, our point of intersection, is x first, so we've got negative 1, and y after that. And not to forget, points are written as x, y. And we are done. So back to our learning goals. Remember in this lesson that we learned to find the point of intersection of two lines through substitution, and we will convert word problems into linear equations in the next lesson. Now try some examples on your own to make sure you've got it.